Okay, so now the finale, part 3, function analysis. And really there's way more that we could be doing with this, but right now we're just going to try and use what we've learned so far, kind of like this introduction to function analysis. So let's look at this information. This is really two problems in one. We're going to be doing part A here first. It says f prime of x is greater than 0. That means slope is positive. And f double prime of x is greater than 0. That means that the concavity is also positive. And f1 equals -2. This is like a start point or a reference point that we can use that's actually in the function. So f of 1 equals -2. That means we're right here. Slope has to be positive. Concavity has to be positive the whole time. And we got to go through that point. So if I'm going to start low, end high, but I got to make it concave up, that means the function that I'm looking at is kind of like this and like that. So notice we have this bend here, and it still goes through that point, and we're concave up. Concavity is positive, but the slope is also positive. We're increasing the whole time. So we're increasing, and we're concave up. Okay, let's look at part B. So this one we have a start point at f of 1 is -1, so now we're a little closer to the axis, right there. Then we got some changes. This is before x, or after x is equal to 1. We have a increasing or decreasing. This is increasing after x is equal to -1. So let's kind of color code that. We are increasing after x is greater than 1. And then it says we're going to be decreasing or negative slope when x is less than 1. And then f prime of 1 is 0, so that means that we're flat at 1. So we're going to be flat here. We're going to be increasing after, decreasing before. So I'm going to just make some values here. That means we're increasing after. We're going to eventually go up, but we're going to come down to start. But now this last piece here, what's going on with this concavity? The concavity is positive, so we got to be concave up. In other words, we got to be a smiley face. Well, that looks pretty easy to draw. So we're going to be coming down, decreasing, but we're smiling. Things are getting better and better and more positive until we are super smiley. Look at that smiley face. So happy. Let's do another one. Now we're looking at, okay, what's happening here? This is positive first derivative, so we're increasing after x equals 2. We are decreasing, no, f prime of x, oh, this is interesting. It is always flat. So this is flat before 2. And we're going to be concave up after 2. And at 2, we're at 1. So that's kind of like the start point. So f of 2 equals 1. So we're right about here. After 2, we are concave up. This is concave up. And we're increasing. So we're going to increase. So if you're thinking about increasing, but then you have two choices for concavity. You can either be like this or like that. One of those is concave up. It's actually the second one that we did. So it's going to be like this. Now, the really interesting thing, I'm going to cheat here with my special flat line, is the completely flat slope before 2. So we are completely flat. That means before x equals 2, it's just a flat line like that. That's kind of interesting. We haven't seen a picture of something like that yet. It's kind of like a piecewise function. You know, one way for a certain point, and then all of a sudden it goes up. Let's look at part D. So a couple of things happening here. First thing I see is this is concave down. It's less than 0, so we're going to be concave down. Sad face the whole time. And let's see, which one of these is increasing? We would be increasing here after x is equal to -1, but we're going to be decreasing here before x is equal to -1. And then our start point is going to be f of -1 equals -4. So f of -1 is -4. We're all the way down here. And we're concave down. So we're going to be increasing after. So increasing after, we're going to be going up eventually. But before, we're going to be decreasing. And we're concave down. That means I actually have to bend kind of like this. Actually, not kind of. That's exactly how it needs to bend. It needs to bend down. Keep missing that point. That's okay. And then we're going to bend down or bend back this way for the after piece. So notice here, we're concave down. We're concave down each time, but we have decreasing before, then increasing after. So that actually winds up giving us a sharp turn. And you know, you could almost imply that, because here it didn't say anything about f prime of -1. Why? Because it does not exist. It's a sharp turn. Derivative's not continuous though. That's exactly what it's saying here. But whoa, this one is a lot. We got a lot going on here. Okay, so first let's talk about concavity. Concavity is going to be concave down to start. And then after 0, it's going to be concave up. We know that we're flat here at 1. And we're also flat here. Now let's look at increasing and decreasing. We are increasing when x is greater than 1. And we are increasing when x is less than -3. So we're increasing on both ends, left and right. But in the middle, we're decreasing. This is the middle. So that means so do we have any like specifics? No, we don't. But we do know that at -3, between -3 and 1, we're going to be decreasing. So I'm going to start high at -3 and end low at -1, or at 1, I should say. Now I'm going to decrease in between those. So I'm going to decrease. But I need to change concavity, which means I'm sad until I hit 0. And then I'm going to start turning more positive after 0. I'm going to be happy after 0. And then before -3, I have an increasing slope. And after 1, I have an increasing slope. So this is what we would get. So notice here, we change concavity at 0. Because we're sad. And then happy after. But we are positive slope here, then negative slope here, and still negative, but then positive slope at the end. All right. It seems like a lot of information, but it all kind of fits together. All right, so so we got a starting point at 2, f of 2 equals 0. That's easy enough. F prime of 2 does not exist. I don't know what that means yet, but let's look at the other things. Maybe it means a vertical line, maybe it means something else. So let's start with this. We have concavity. So this is going to be concave down after x equal, or yeah, when x is greater than 2. We are going to be increasing after, but at negative 2, before 2, this is actually interesting. This is 0 concavity. It's constant. We're linear because it's a constant slope, and it's constantly negative 1. So that's why. Oh, okay. So here we're going to be a constant slope of negative 1. So that means we're going to go down 2 over 2. So we're negative 1. Constant slope. Straight line. And then we're going to be concave down afterwards. We're going to increase, but we got to be concave down. And the only way we can be concave down is if we bend up like this. There we go. And then we get the sharp turn. That's why f prime of 2 did not exist. Whew, that was a lot. A lot of information there. Okay, so now that we have kind of that information established, we're looking at the first and second terms. We can attack the problem algebraically. So we're going to do all this on our own. We're not going to have them give us the information. We're going to develop the information ourselves. And you know what? Just for time's sake, I'm going to actually stop the video here, make this into a 4-part series, just to kind of give you some breaks, and maybe help your computer download these. Maybe even easier if you want to take them with you. So I'm going to stop the video here and make a part 4.